Hello and welcome back to Calculus 1 with K's because of Mike. So we are talking about the connection between derivatives and integrals. I did mention before that in mathematics we have operations like addition, subtraction, multiplication, logs, and these operations, mathematical operations, change numbers into other numbers. For instance, 3 plus 5 is 8. Numbers 3 and 8 were combined, numbers 3 and 5 are combined into 8. 3 minus 5, negative 2, right? Log 2 of 8 is 3. So we can combine numbers using operations and get new numbers out of that. But then we have operators. And mathematical operators change functions. So they operate on functions and change functions. So you have derivative operator. Derivative operator would take a function, say x squared, and change it into 2x. Different operator would be integral operator that will take, let's say, x to the 7 dx and change it into x to the 8 over 8 plus c. So the function on the left and function on the right are not the same function, right? In the first case, you have quadratic, and then you have a linear. Second case, you have two polynomials, but one is of the order 7, the other one is the order 8. So the question is now, how do these relate? And we do that using fundamental theorem of calculus. It has two parts. So fundamental theorem of calculus, FTC, part 1 is just your definite integral calculation that we covered so far. And that one is that the integral a to b of f of x dx is any antiderivative computed from a to b, which is f of b minus f of a. So this is fundamental theorem of calculus part 1. And this actually tells you how to compute definite integrals. The examples of this you've seen last class. Integral from 3 to 6 of x squared minus 1 dx. So our antiderivative here would be x cubed over 3 minus x, all of that computed from 3 to 6. We plug in 6 everywhere, which is x to the 6 over 3 minus 6. And then minus, we plug in 3 everywhere, which is 3 cubed over 3 minus 3. And now we do fair amount of arithmetic. Wait. Yeah, thank you for the moment. So, yes. So now, instead of writing this as 6 times 6 times 6, I'm going to say 6 times 6 times 2. So that's 36 times 2. Because the last 6 canceled with a 3, right? Got a 2 up there. Minus 6 minus 9 minus 3. Because, again, one of the 3's cancels. Good evening. So now, this is 72 minus 6 minus another 6 for a total of 60. So this is computing the definite integral, what we learned last time. And that's also the fundamental theorem of calculus part 1. We also learned that this gives us the area under the curve as long as the integral is not going below x-axis. And if the function does go below x-axis, you have to cut that piece off and use the absolute value on its answer so that we don't get negative area, subtracting, and all of that stuff. So, here, in blood, area under the curve is not always equal to the value of definite integral. Here are the cases. If the f of x looks something like this, from A to B, in this case, so let me shade, this is our area. In this case, in green, they are equal. Then, I give this as an example. And I'm looking, let's say, for this in red, they are not equal. Because the part of function that goes below x-axis is creating negative area, it will subtract from this part, and then the total net area here would not be how much we shaded. This is the part where we have to split at x equals to c. So your A and your B, right? Black. So A and B is the main interval, but now there is a C. So you have to go integral A to C plus absolute value integral C to B. To get the area. So definite integral and being able to compute definite integral is not the end of the troubles. You also have to be very critical, right? And mindful of what kind of function you have and whether that function dips below x-axis or not. So you need to be able to do that. Second part is Fundamental Theorem of Calculus Part 2. Fundamental Theorem of Calculus Part 2. And this one says integral a to x of f of t dt is equal to f of x. Oh, there's d dx in front. Oops. There we go. Much better. So what does this technically say, keeping in mind that this is the lowercase f and this is the lowercase f as well? What does this technically say? Yes, it says that technically derivative and integral cancel each other out and you have f equals f. Technically that's what it says. But now let's take a look at the proof of this, and that should make a lot of sense instantly. I have the derivative of the integral a to x f of t dt. Copy the derivative part. So now we know that this is supposed to be any antiderivative, so capital F of t, computed from a to x. Now, copy our derivative. We have f of x minus f of a. But now when you take the derivative, see, this is f of a. This is just a number, also known as a constant. So we have f of x minus 0, which is just f of x. It's really cool, very quick proof. And it's actually calculation. So we integrated, we got the antiderivative, and then here we differentiate that antiderivative and we get the original f back. Now you note that these are t's and these are x's. Well, that's just we call this as a dummy variable, because you really don't want to have this in terms of x and then the x limit, right? The question is, why does it work? Why is the definite integral and derivative, why they're opposites? How does it work? Does anyone know? Does anyone think about it? No, I'm taking the derivative in respect to x. Right? Because the answer will be in respect to x. Why are these opposite? What was the limit formula for f prime?
Limit x goes to c, and x goes to h.
I heard h.
H goes to 0.
Okay. Very good. Great. What was the limit Riemann thing for integrals? Limit like if there's one thing now from chapter 5 that I have to add to the test, would be this one.
And goes to sigma n over I equals 1.
Does this help? Why are they opposites of each other? Look at the formulas. And if you are thinking, is this really that easy? Yes, so say it. Perfect, there you go, one of them. 0 and infinity, that's opposite, great. What else?
Probably stupid answer that one's addition and the other's subtraction.
That's exactly what it is.
Okay.
This one over here is subtraction, this one is addition, good. What else? So you have this pair here, you have this pair here. What else? Yes, the division and the multiplication. There you go. Uh-huh. Yeah, exactly, middle school. Like what's different between them? This is technically like, you know those images when they give you two pictures and you have to see what's different between them? That was actually that. I'm serious. You can get the app on a phone and play it. So, yeah. Now you see why derivative and integral are completely opposite and undo each other. all of the operations involved are opposite, right? And then if you go, but you have addition over here, sure, I have a subtraction over there, right? It's b minus a. So there's that. Good. So we have completely, we've written these formulas out. We've seen that they're completely opposite. And now we can also take a look at one calculation problem. So what is the derivative of the integral of e to the 3t minus t squared dt from 6 to x? What do you mean? T? Yes. E to the 3x minus x squared. Has to be in x's. Good. So you already know the answer. The answer is e to the 3x minus x squared. Done. Right. Why? Well, compute it. What is the integral of e to the 3t? Over 3. Good. And what's the integral of t squared? T cubed over 3. All of this needs to be computed from 6 to x. So d dx, plug in x. What do you get? You get e to the 3x over 3 minus x cubed over 3. And then minus, plug in 6. E to the 18 over 3 plus 6 cubed 72. Now you're supposed to take derivative. The derivative of the first one is you copy the constant, copy e to the 3x times the derivative of the inside, which is 3, minus, copy the constant, and then you have 3x squared minus 0 plus 0, derivatives of these constants. E to the 18 is a constant. There's no variable there. So please don't, write stuff. E to the 18 is just a number. There's no variable, so the derivative of it is 0. 1/3 will cancel the 3, and 1/3 will cancel the 3, giving you exactly what you wanted to see, and that's e to the 3x minus x squared. No plus c either. It's just this. No plus c is a definite integral. No, there's no indefinite for this. Definite integral and derivatives are opposites of each other. So the formula here allows us just to write immediately without computing all this stuff. Right? The formula allows us immediately to write e to the 3x minus x squared and move on with our lives. Good. Fundamental theorem of calculus has two parts. Part number 1, the way to compute definite integrals. Part number 2 is the one that connects derivatives and integrals as operators. You have to worry about the area not being the same as the value all the time. Sometimes it is, if all of the functions above x-axis, and sometimes it's not, when it dips below. Fundamental theorem of calculus part 2. We have derivative of the integral. They technically cancel. You get your original function back. The proof in blue and example over here at the end. Bye.